In this video, I'm going to show you a simple but effective way to save costs when working with LLM applications, particularly when your users ask similar questions over and over. So here's what we'll do. We'll be working with a HR application which answers employee questions. So questions like, what is the policy on paternity leave, to how many holidays do I have, all those kinds of questions. And to demonstrate this, I'll ask a question like, let me turn off this cache first of all. I'll say, what is my PTO, which is paid time off? Now, what's going on behind the scenes is the LLM app is retrieving the policies based on this markdown file which I had created, and then it finds the policy for EMEA because that's where the current user is, and then returns that back to the user. So this is Sam. Sam is in EMEA. It returns the answer back to Sam. If I ask a similar question, which should get technically the same answer, like for example, how many holidays am I entitled to? This still goes to the LLM because LLMs by nature are stateless. They don't remember what you've asked in the past. And you could see you get same answer but slightly different voicings from the LLM. But pay attention to this part. You can see the costs here. I'm trying to see if this is working. The cost, this is taking 7.8 seconds and costs this amount. This is taking 6.45 seconds and costs this amount. So if I turn on the semantic cache, which is the solution to this particular problem that I want to demonstrate, and I ask a question like, okay, how many vacations am I entitled to yearly? Watch what happens. It just retrieves directly from the cache and then returns the answer back. And note this point here. It takes less than 1 second to come back with costing you nothing. But here's what's interesting. You can reuse this answer for other users as well. So if I come to page is in EMEA as well, and I say how many holidays or how many PTO do I have? This comes from the cache as well, and again you can see the latency 0.187 seconds with it's costing you nothing. But if you come to another user called Mark, and because Mark is in APAC and our HR policies for APAC is actually different, and I ask a question like, how many vacation days do I have? It goes to the LLM because it's a different scope of users that we're dealing with. And then from the LLM, it gets 18 days, which matches with the 18 days that we have here. So that's the demo, but how does this work very, very quickly? Well, the main thing is semantic caching. Under the hood, I'm using Redis to power this, but here's how it works. Typically, when a user asks a question, you're able to send that question after pre-processing or doing some further validations. Send that question or query to the LLM alongside the context you need, RAG, extra data, etc. The LLM returns the answer back to you and return it back to the user. But in the cases where you have users ask similar questions like, hey, how do I reset my password? I need to reset my password. Those are similar. What happens is the first time the user asks a question, you check your cache, but not just any kind of cache. You check a semantic cache, which essentially stores the vectorized version of the question as the key, and the LLM responds as the answer to the cache. In the first instance, obviously, there's nothing in the cache. So it comes back and then invokes the LLM, right? And the LLM comes back with an answer, and then with the answer, you can then return the back to the LLM. Yeah. So the LLM comes back with the response, and once you get the first response, you store that in the cache. And then the second time a user asks a similar question, it just needs to check, is this question similar to what has been asked before in the cache? If it is, it returns that answer. There are two quick questions people might ask there, like, how do you even measure similarity? Well, I've got a quick demo around this for you. Well, the main answer is you use a threshold, a similarity threshold. Because essentially, when you're working with vectors and you want to find out how similar two vectors are, say using cosine similarity, you want to have a particular point in which you can say, if the similarity passes this particular point, I consider these two vectors or questions or statements similar enough. In our case, we have this as 70, but this number is usually dependent on your tests. So it's usually a good idea to first of all retrieve questions that you see users asking frequently, and then create an eval set based on this and see, okay, well, am I getting a good threshold based on the response on the questions people ask? But then you can also like choose your embedding model. So in this case, I'm using the text-embedding-ada, but you could use other models as well and compare to see what works best for you. And the embedding model really just accepts a string and then outputs a vector, which is a list of floating numbers essentially. But it outputs these vectors in such a way that two strings which mean similar things are close together in vector space. But then the next question is, how do you define what to store in the cache, right? And this is really, really interesting, because if a user doesn't ask what is my PTO, maybe a user just says something like, I don't know, good morning, you may not want to store the response to good morning in the cache, right? You might want your response to be a bit more you might want to filter the responses you store in the cache based on certain criteria. Well, one way people do it is to not store anything directly in the cache initially, but have the question, the response going through a secondary cache, and then you could have a human and then decide what goes to a main cache that you store. The other approach that I'm using here actually is the LLM decides. So I've exposed tools, a simple tool called save to cache or something like that, which the LLM can call if the LLM believes that this question is going to be repeated by other users, and then it just does that for you. These are the two ways I have in mind. I'm happy to go deeper into the architecture and how this works under the hood, but I wanted to just introduce this to you. I mentioned earlier that you can put scope in, but that may be a video for another time. Let me know if you've got questions. I will be posting the link to this breakdown of semantic cache. This particular application is powered by Redis. Redis vector library powers this under the hood. And yeah, that's it. Now, just a few quick things to keep in mind. It depends on how dynamic of volatile the data is. Data that change really quickly. For example, a data that asks, what is the stocks today? You might not want to cache that for just the duration of today. Sorry, what is the best stock for today or something? Or what is the price of, I don't know, of Tesla today? You might want to set like a time to leave, or not store really dynamic data like that, and maybe less dynamic data like, hey, how many vacations do I have? If it's dependent on the location, that can be cached. So there is nuances to think about in how you think about what to cache in the first place. And I was also going to say it's usually useful to like start with a very small sets of data to go with. But yeah, let me know if you've got any questions on this, and see you in the next video. Bye.